Okay, so Java, as we've been talking about, is object-oriented. Actually, no, I'm going to start somewhere else. So when you run a program, what is the function that Java looks for to start execution? What's up? The class, but what in that class does it go to? Which method? Sorry, who said that? The main method, yeah. So Java will look at whatever class you have decided to run. Let's say it is Monte Carlo.java. Java, and it will look for wherever your public static void main method is. And let's say main has a bunch of lines of code, yada, yada, yada. Java will go to that main method and start executing lines of code one by one by one. And that's the thread of the execution. So if we picture like a timeline here, this is your main method. And as the program starts, it starts to execute. Now, you may have yesterday in lab called a method, as they're called, the square root method. So math.square root sum value. Say like 4.0. When Java hits a what are called method, it stops the execution of the main method and starts execution of the square root method. So it hands over control to another method in the Java program. And methods are just similar to the main method, bits of code that can run sequentially. So let's say you call the square root method, the thread of execution switches over to the square root method and continues on. When that square root method is done, it returns back to the main method and continues on. And let's say you had a third method called foo, and then you call that later on, switch to there. Let's say in the foo method, you call the square root method, you could go back down to the square root method, and then back up to the foo method, and then back down to main. So when you run a program, it's not just going through main, line by line, executing. Every single time that you call what are known as methods, you switch execution to that method. And you'll get a lot of practice with writing methods and using methods. And there are different flavors of methods that we use throughout the class. And one of the flavors is static methods, which we'll talk about today. Does this make sense to everybody? Cool. So in this class, at least, methods come in two flavors. They come in static and instance. Today we're going to be talking about the former. So methods are just boxed up bits of code at their simplest form. Called on instance, we won't talk about today, or they can be called from static context. So I've been telling you to think about all of these, or all Java programs as classes. So a good example here would be car class. I'm going to use it again. But there's another class type, let's say the math class over here. The main difference between static methods and instance methods is the context in which you use them. So an instance method, I'll spoil it a little bit, needs to be called on an instance of a class. So let's say you have a car class. What is the shape of a class? Neuron activation. What was it? Rectangle, yeah. You have a class which describes what? Or which does what? Going once.
Describes an object.
Describes an object and all of the things that it can do, along with implementations, right? So this is going to describe what a car can do and how. What a car can do and how. Those implementations. So it might have a drive method, it might have a park method, it might have a radio method or play radio method. And once you have this blueprint for the car, you can make as many instances of a car as you want. You can make Steven's car, S car. You can make T car, my friend Teddy's car, way nicer than mine. You can make, I don't know, E car, my sister's car, Emma. All of these are instances of a car which are separate. So there are distinctions between the different objects that we are making. There's a distinction between my car, my friend Teddy's car, and my sister Emma's car. Now, if that distinction matters when you're calling a method, it's going to be an instance method. So if I call a drive method, it wouldn't make sense, or it makes sense that you have to call that on an instance of a car. So if I have scar.drive, it's very different to call scar.drive than it is to call tcar.drive, because they are different objects. The object on which you are calling the method is important in this case. Those are instance methods, and we get into all of their nitty-gritty details a little bit later, but that's a bit of a teaser. If the instance of the object does not matter, you write what is known as a static method. So if you're thinking about the square root method, it wouldn't make sense to have different instances of the math class. Math is math. It doesn't matter what type of math, or math doesn't differ. It's static, it doesn't change. That's when you would use a static method. So when you use a static method, instead of, it depends on what class you're in. So let's say, again, you're in the Monte Carlo Java lab, right? And you have your main method, starts execution. In order to call a static method that is outside of the current class, you have your Monte Carlo.java, and somewhere, somebody has written a math.java method. You invoke the name of a method by calling its class. So in this case, we call the math class. And we call the method in that class that we would like to invoke. In this case, the square root method. So that is the instance in which you would use a static method, is when the context of the code that you're running does not depend on which type of object you're using. So a static method or a class method is a block of code with a name using which it can be called to perform its computation. That little picture I drew earlier of the threads of execution, the method takes over execution when it is called, and it returns to the calling program at the point at which it was called. Other names for this are routines, subroutines, operations, functions, or procedures. The main purpose of methods is to reduce the clutter of code. So you could probably, given enough time, write a square root method, or write the logic to compute a square root method. But if you wanted to calculate the square root of a value more than once in your program, it would not make sense to copy and paste the code to calculate the square root over and over and over again every single time that you wanted to calculate the square root. So what we do is we take that code, we bundle it up, we put a nice little bow on it, and we call it a method. And that way, you only have to call that method, and you can switch the execution to the square root code that you've written as many times as you want, and it can calculate the square root for you. How do we feel about this so far? Methods are awesome. Without it, code would be boring. Okay, so let's switch back to bio and talk about the anatomy of a static method. I'm going to erase this. Is that okay? So a static method, or writing a static method, is going to look very similar to this example up on the screen. We have a private static int distance. We can talk about each of those. So, private static int distance. Each of these four things is important. And then it takes in int A and int B. So this is an example of what one static method might look like. The first word is a keyword, private, which defines the scope of the function. So let's say you were writing this in a foo.java. Then you also had another file in your program called foo2.java, the sequel. And they each have their own main methods, yada, 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 like so. Let's say in foo.java, you are going to write this private static int distance method. Private versus the other one that we might use, public, defines the scope in which that method may be used. So let's say you are writing the foo.java method and you don't want any other files to be able to use the foo.java method. You would make the method private, which means it can only be called within the context of its own class. So pretend this is the method header. I'm just going to say distance here. We wrote our static method. Anywhere in this code, you could call the distance method. That's fine. It'll switch execution to this block of code, switch back, so on and so forth. If I wanted to call the method in foo2.java, I would be unable to do so because it is in another file and it's private. So that's essentially saying, hey, this is my method. Don't let any other files use it. Does that make sense? Nods. Static, we just talked about, is the context in which the method can be called. So in this case, we're saying, hey, distance doesn't really matter. It doesn't need to be called on a foo object. You can sort of just call it. When you are calling it, you simply invoke it using its name. So in this case, distance, and that's how we've called it in foo.java. Let's say, hypothetically for a second, that we made this method public. A public static method called from another class. Let's say we're switching context here. We're now in foo2.java, and we want to use this distance method that has been described in foo.java. What we need to do is invoke the name of the class where the method is coming from. So the distance method is described in foo. So I want to call foo. I want to go to the foo class, and I want to call the distance method. And I can do so. Let me put this another way. You have math.java. And then you have Monte Carlo. I'm going to say mc.java. In your Monte Carlo.java code, you called math.square-root. So square root is a public static method which exists within the math class. And when you wanted to use it in the Monte Carlo.java file, you called math.square-root. You invoked the name of the class which you would like to pull the static method from, and then you pulled the name of the method that you wanted to call. So that's static. And we'll get into its brother instance methods later, which are also cool. All right, that's the second piece. The third piece is what's known as the return type. So this is like the context. So oftentimes you'll want to return some bit of information from the method back to the user. So in the case of math.square-root, it returned, I believe, a double. But you can also have functions that return strings. You can have functions that return integers. You can have functions that return pretty much anything. If you would like the function to not return anything, it's known as a void function. And it does not return anything. Now, keep in mind that if you define a return type, so if I say, hey, this method has to return an integer, that method has to return an integer. We talked about if statements. No matter which thread of execution or which path of if statement you go down, at the end of that function, it needs to return something. So you can't say something like if A do something else return. Because if A happens and you go into that section and then you skip over the else block, you're not going to return something. This is why in our best practices for Java page that's on Carmen, it says that you should not use multiple return statements, because the best practice that we want to get across to you is that if you're returning an integer, you should define that integer either at the top of your program or as near to the top of the program as you can. And the last sentence or the last statement in your code should be the return statement, which returns that integer, string, double, character, so on and so forth. Does that make sense? Cool. And then the final thing is just a name. Or sorry, not the final thing, but second to last thing. So the name of the function is just a name for the function. So sqrt, square root, power, POW, so on and so forth. Finally, we have an optional thing that we can add, which is 0 or more formal parameters, as they're called. And these are variables that are passed into the function upon calling. So the math.square root method, I hate to come back to them, but it's so useful for examples. Took in a double value. So it took in a value that you wanted to take the square root of. So in this case, 4.8. And what happens, passing arguments, as what they're called. So when you pass in something, it's called an argument. And at least for primitive types, like doubles, it is copied into the formal parameter. So a better example, I guess, is to use the one that's just on the board, which is distance. If we wanted to invoke this distance method, this distance static method, and say, again, it's defined in the foo.java class, we could call distance, and then we need to pass in two integers. So let's say 4 and 10. Now, 4 and 10 in this case are copied into A and B. So anytime that you use A or B within the function or within the method, you're referring to these values that have been passed in. And these don't even have to be literals. You can have int x equals 4, int y equals 10. And you can pass those in as well. As long as the type of the value that you're passing in matches the method signature, as it's called. So this distance method we're saying is private. That's right there. That should only be able to be called within the method or within the class that it's defined in. That's the scope. We're saying it's static. It can be called within the context of not needing an object to call on it. And to return an integer, it should be called distance, and it should take in two formal parameters, an integer A and an integer B. Are we good on that? Yeah.
What if you put in like a double for A?
Java will yell at you. It will say, we'll actually get into that, but this right here, distance into A and B, is called the method signature. And if when you pass it in, let's say you passed in 4.0 and 10 distance. What Java does is it says, let me look at all the static methods that you have made, and let me look for one called distance that takes in a double and an integer. And it won't be able to find one, so it'll yell at you and crash. Okay. That is the distance method. So the method header, which is this entire thing. So we're looking at the anatomy of the header, or the anatomy of the method. The header includes the method's return type, its name, and its parameter list. So this right here, whole thing would be the header. The method name and the parameter types compose the method signature. So a subset of that is the signature. Now, it's called the signature because, like in real life, all signatures are unique. So you can't have two distance methods that take in two integers A and B. You're not allowed to. Now, we'll get into something later called method overloading, which is the case where, say, you wanted to make a distance method that calculated the distance between two doubles. So we had distance double A, double B. Java will take a look at what you've passed into the function. Let's say you call distance 4, 10, and then you call the distance 4.0, 10.0. This first time when you call it, Java will look at all of the static methods that you've made, and it'll say, okay, I have a distance function that takes in two integers. I'm going to run this version of the distance function. The second time you call it, Java will take a look at all of the static methods that you've made, say, okay, I have a distance function that takes in two doubles. Let me run that version of the code. So it'll look at what type you've passed in, and that is what determines which distance method it runs. And we'll get into that. But teaser. So method header versus method signature, important distinction there. What's known as the method body consists of the block of code that is executed when the method is called. So when we switch our thread of execution from the main method to a static method or an instance method, it runs all of the code contained within the curly braces. And this method is very simple. It calculates int d the distance between B and A and returns that back to the user. Good so far. All right. It's important not to forget about the return type or forget about what is returned. So something that is returned from a function is just the return type. So an integer is returned from the distance. So you could say int x equals distance 10 and 4, and little awakeness check. What would the value of x be after this method is called? -6? Wait, yeah, you're right. Thank you. Yeah, -6. Because int d calculates the difference between b and a, so 4 minus 10, and then that is returned back and stored in x. You could print out just the result of distance. So 4, 10. Okay, in this case, what would the resulting method print out? Distance 4, 10, 6. The third thing you can do is you can use the resulting result of a method as an argument or in place of any other integer you need. So let's say we wanted to call distance, and instead of passing integers in, we passed in the result of distance 4, 10, and then the result of distance 10, 4. What Java will do is we'll go in here, it'll say, I want to calculate the distance between the resulting values of distance 4, 10 and distance 10, 4. And it'll do that and return that integer. You can store that in, say, int x. Those are the three main ways that you're going to use the returning method. A lot of people sometimes might just call the distance function and then be like, well, where's my variable? You have to put it somewhere. Java will calculate it, but if you don't have int x equals or out.println equals, Java will say, okay, I did the distance, and then it will just throw away the value because you're not storing it. Okay. Private limits the places from which the static method may be called only from within this class. Public here would allow it to be called from other classes too. That's this right here. So foo_true.java, in the case of a private static instance method, would not be able to call the method in foo.java, and so on and so forth. Int means the method provides a value of this type to the caller when it returns. Void here would mean that the method returns no value at all. So if you want a method that just prints a bunch of stuff or does a bunch of stuff and then doesn't return anything, that's a void method. Distance is the name of the static method, which is used when calling it. So anytime you want to use a method that you've defined, you call it by using its name. All right, int a is the first formal parameter, as they're called. So in the method signature, they're called formal parameters. But when you're actually passing them in to calls to the method, they're called arguments. So that's a distinction as well. So you have 10, 4 versus A and B. Now, let's say, for the sake of the argument, you have X and Y. Let's draw the boxes that we were using the other day. X, Y, and 4, A, B. All primitive types, so integers, characters, doubles, booleans, are what are known as pass-by value. So what will happen when you call the distance formula is it will say, hey, what are the values of X and Y? Oh, 10 and 4. Let me just copy their values in. And it'll do computation and it will return. Let's say in the distance function, instead of the distance function being what it is, it just takes A and it subtracts 1 from it, and it takes B and it subtracts 1 from it. So afterwards, we have A equals 9, B equals 3. When you go back to the main thread of execution, X and Y are still 10 and 4. Just because you updated them within the distance method does not mean that they get updated outside of the method. This is like a huge concept that a lot of people miss. So primitive types are passed by value, meaning that before and after you pass them into a function, their values are going to be the same. That's the simple part. We'll get into what are known as reference types, where this is not the case, where let's say you pass X in somewhere and then you modify it afterwards in the main method, it will be different. But for the case of integers, doubles, booleans, all that good stuff, pass by value means that the method will not change the original values. Cool. Is that good? Okay. Int d is a local variable of the method. So we talk about a variable scope, which is the context in which it can be called. So in this distance function, we have an int d equals b minus a. The scope of this variable is only within the distance function. So if we're back in the main method and we try to use d, print out d, pass it into a function, Java is going to yell at us. It'll say there is no variable d because in its own head or in its context, the main method context, there is no integer d. It's only contained within the distance method. So that's a variable scope. It's called a local variable. Return is a statement that hands control back to the caller. If a value is returned by the method, then an expression after return provides this value. So we're saying we want to return the value of d back to the user, and the user can do with it what they will. Print it out, store it in a variable, use it as an argument, whatever they want. All right. Okay. Every path of execution through a method that returns a value must end in a return statement with an expression of the return type of the method. A method that does not have a return may have return statements with any such expression, but by default, it returns to the caller anyway when the method body completes execution. This is essentially saying, no matter which path you travel through the code, it must return whatever type you specify. So at the end of any function, you have to return an int. At the end of a double function, you have to return a double. Otherwise, double will go. Yeah.
Could we just put return or would we have to put?
You have to put return an expression, and that expression must be of the type that it returns. So if it's an int, you have to return an int expression, string expression, so on and so forth. Okay, that is, I believe, the last of static methods. Yeah.
It says return, it must return an expression no matter what path it takes.
Yeah. So if you had, say, if something, you do something else, something, you do return X, and you go down this path of execution, and you have nothing else in the function, in that case, it won't return a value, which is illegal, and will get you thrown in Java jail.
Will it run or will you get an error?
You'll get an error.
Okay.
I think so. I think Spotbugs flags it.
Okay.
Or Checkstyle might flag it. One of the two will say like, hey, every path of execution must return something. Okay, any other questions on static methods? A lot of the time, the coding portion, I guess I can, so the structure of the midterms is usually multiple choice, some form of like short answer or diagram drawing, and then usually you'll have one or two coding questions where you are writing a static method or you're writing an instance method and you have to provide an implementation. So writing code on paper, not on a computer. It's fun, I swear. Okay. But you'll get a lot of practice writing it. I would say you want more practice, consider, especially if you're practicing using like the practice midterms that are in the test bank. I would not try to write the code in Java or in Eclipse. I would actually sit down and write it pencil and paper because it'll give you practice with writing code using a pencil and paper, because usually sometimes that'll trip people up. All right. The second part of today's class is just going to be tracing through a while loop. So getting some more practice with what's it called? Tracing tables. So we consider the function here or the static method here like so. We have is I equals 4. Can somebody call out what the next things are? A equals 1 and then n equals 0. 0, the box. While I is greater than j. if n modulo 2 equals 0. Who remembers what this is testing? The remainder, but what more specifically? Even or odd. It will check whether n is even or odd. If 0, it's even. It's odd. Minus j plus plus. Plus okay. So we're just going to get some practice going through the tracing table for this. So we have like lots here. Let's go. Okay, so after the first line executes, what will the value of I be? 4. Nice. What will the value of j be? 1. 1. What will the value of n be? This first Boolean expression right here, while I is greater than j, are we going to enter the while loop? Yes, because I is greater than j. After that, what's the value of I? 4. What's the value of j? 1. What's the value of n? 0. Okay. If n modulo 2 equals 0, is that true? Yes, because 0 divided by 2 is 0, which equals 0. Once we get in here, what's the value of I? 4. What's the value of j? 1. What's the value of n? 0. Okay. Then we call I minus minus. After this, what is the value of I? What is the value of j? What is the value of n? 0. Okay. Do we go into this else block? Nice. Okay. And then we'll go down here. After all of this, let's skip over this part because it's the same. What is the value of I? 3. What is the value of j? And what is the value of n? Okay, I'm going to make an important distinction here. Even though you don't go into this thread of execution, what you do is you draw a slash or you draw a blank to indicate that that thread of or that path throughout the code was not taken. So let's say j equals blank or n equals 0. So upon this first pass, we did not go through this path to the code, so we write down that it was skipped. Okay, is everybody good with this thread to the execution? So after we hit the bottom of the while loop, we go back up and we say while I is greater than j. So in this case, we redo our values here. So what is the value of I? It's 3. Value of j is 1. And the value of n is 0. Actually, I don't think we update this. Actually, no, I think we should. 1, 0. So now we say, is 3 greater than 1 or j? Yes. Oh, wait. 1. Yeah. Now, if n modulo 2 equals 0, is this true? Why? Yeah. 1 divided by 2 is 1, or its remainder is 1. So this is not true. So we put backslashes here to indicate that this is skipped. This is skipped as well. And then we go down here, j plus plus. So the value of I in this case will be 3. The value of j will be j plus plus, which is 2. The value of n will be 1. And then down here, the values will be, so we have 3, 2. And in this case, it'll be 2. This was actually 1 before. The big thing with tracing tables is you can look at any column of the tracing table. So let's say this first column here. And you can see what the values of that particular run through the while loop was. So the first time we ran through the while loop, the value of I was 4, 4, 4, then 3, then skipped, then 3. You can do that for every column, as long as you keep the values the same. Another thing to note is that you don't have to update these because we don't go back up out of the while loop. A lot of the times people will update these values that are before the while loop. You don't need to do that because they are not ever executed, or you don't ever go back outside the while loop above it. You start inside it.
So we're supposed to run these, like, for the tracing, we're supposed to do it until we can.
Yeah.
Okay.
So, third time we run through, I, 3, J is now 2, and is now 2. So we can see first time through, it was 4, 1, 0, then it was 3, 1, 1, then it was 3, 2, 2. It's easy to see at any point throughout the code what the values were. Okay, 2 modulo 2 is 0, so we go in here, we say that I is 3, 2, 2. I minus minus will give you 2, 2, 2. You skip this, so you have backslash, and you go down here, and finally you get 2, 2, and we increase n, so it's 3. Okay, now when we go back up to the while loop, we have while I is greater than j, what is this going to return? Who said that? I heard it. False. Why? Yeah, I is not, or sorry, I, which is 2, and j, which is 2. I is not greater than j. It's equal to j, which returns false. So we go back outside the loop, and then the final values we have are I equals 2, j equals 2, and n equals 2. I think all of the slides just do this, but in a much more formatted way. So you can see 4, 1, 2, 4, 1, 0. And then I think he skips over. Yeah, so he uses slashes in this case to indicate that the else loop was skipped over. You can also use spaces and just line everything up based on what level or what pass through the first, second, third pass through the while loop you're going through. It's up to you. And then if we scroll down to the final one, 3, 2, 2. Uh-oh, did we mess something up? Did I mess something up? Oh no, 2, 2, 3. Okay, cool. What does this do? So describe in English, now that we've gone through the math. We passed in I equals 4, we passed in j equals 1, and we passed in n equals 3. What does this compute in English? Take a minute and think about that. I'll go back up to the code. Stay here till 8:55 if nobody wants to answer. Okay, your first hint. Think about, look at where did my chunk go? Think about the relationship between n's final state and I and j's initial states. Think about the relationship between the two. Yeah.
Let's just find the difference.
Yeah. So I is 4, j is 1. Afterwards, n is equal to 3. We go through, and while they're not equal to each other, we increment or decrement one of them, and then increase n, which in this case is just a counter variable. And at the end, n just is the distance between the two. So it's a very convoluted distance formula compared to the one that we wrote up here. So if you want to be pedantic, you could write a distance formula like this, but please don't. Or do, I don't know, it's your life. Okay, any questions on tracing tables and or static methods and or anything else? Okay, gift of time, 12 minutes early. You guys can get out of here. I will see all of you for lab tomorrow. It's a good one. They're all good.
What was the attendance question?
Ah. It was, why did you show up late to class? No, it was, what is the value of X after this runs? What is X?